Hello world, my name is Stefan, the Flashover, and welcome to Let's Code. Sorry for the delay, my monitor over there froze, so I had to restart it. Just let me briefly check if the audio and everything is okay. Test, test, test. Excellent, seems to work. Okay, now I'm here. Hello. Thank you very much for joining. Today I am launching a new series of building a benchmarking library for Roslyn components, where Roslyn components are elements such as analyzers, code fixes, diagnostic suppressors, code refactorings, but also generators such as source generators and incremental generators. And in the last episode, a couple of weeks ago, we started benchmarking an incremental generator. So this is where we basically gonna pick up and put this into a reusable library that then can be used across many source generator projects. But also we're going to build the other Roslyn components. So similar to the Microsoft.codeanalysis.testing package that we have here. If we follow that, this is a set of NuGet packages where we can unit test analyzers, code fixes, code refactorings. These analyzers also include suppressors because a diagnostic suppressor is derived from a diagnostic analyzer, and source generators, both supporting the Roslyn 3.8 source generator, but also the Roslyn 4.0 incremental generator, which has been added in .NET 6 SDK. And we will start with the latest addition to the Roslyn components, the incremental generator, and then basically go back in the when those features were introduced in the reverse order. I will put this link into the chat. So this is, as always, serves as a collection of links. After the session, after this session today, I will add, oops, I forgot to fill the agenda. I will add all the links that we have encountered. As a beginning, I want to make a shout out to Jason Bogg, who basically gave me the inspiration of putting this into a library, because he also streamed in his random.code sessions about how to increase the generator performance of his library ROCs, which source generates mocks for unit tests. And the setup that he's using is quite similar to the setup that I was using, so it seems to be something very common, and common in the Roslyn component world, and also quite reusable and usable across multiple projects. So we will try to make this a more general approach which can be applied to multiple projects. I linked here a couple of YouTube's video to if you want to have a look at his approach. The main usage that I would like to design this library is to be used with benchmark.net. I guess this is the benchmarking library in the .NET space. We've also used this in the previous streaming sessions. So this should be the primary usage. But it shouldn't have any dependency to benchmark.net actually. It could also be used with a different approach. Okay, I have linked this issue here, which is basically the very first issue. Oops, that's not it. That's it. Which is the very first issue in this new repository that I created just yesterday, where we want to support all those types that I mentioned before. And we're going to start with the incremental generators. And this library is the naming and the package structure is inspired from what I showed previously, Microsoft.codeanalysis.testing. And I called it f0.codeanalysis.benchmarking. So how does a benchmark look like? For example, this is now a benchmark that I'm using in this project where we have an analyzer which creates a faster variant of the two-string overloads for enums. So we have here a benchmark where we basically have the log level enum, which is for Microsoft.extensions.logging.abstractions. I think it's in the abstractions package, yes, in the abstraction package. And we are going to use this generated version, use the two-string from the BCL. If we step into, we see this is from the two-string from the BCL, but also the enum.getName, which is also from the BCL. And this generated version is enuminfo.getName, which is a very naive implementation. It has no reflection. It's just a lookup which basically maps the enum value to that to the name of that constant as a string. And if we have a look at the benchmark results, okay, this is not the benchmark result of the generated code, but of the generator actually, because wrong context. I wanted to have a look at the generator code. So this is now the benchmark of the source generator, where we set up the code, which is very similar to the testing. If we have a look at a unit test of this analyzer, which is using if we step into that and into that, eventually using the types supplied in Microsoft.codeanalysis.testing. And we also, for the test, we set up the code as a string so that the user would write. And then we check if it's the generated version that we expect. So here is, I simplistically generate or assemble, better to say, the expected string depending on the language version in use. And then basically do internally does eventually a string comparison between the expected source and the generated source, because the generated source code is just a string. And now this is how a benchmark could look like. So we create some benchmarking type, we feed in the code, and in the global setup of benchmark.net, we here only set up the code. The library should be later on more powerful to also allow setting reference assemblies, such as, okay, I'm targeting, let's say, net standard 2.0, where the nullable attributes are not available yet. And perhaps the other benchmark is using benchmark.net 5 or 6, where the nullable attributes are available actually. So we have an initialize step where we set up all the code. This is not part of the benchmark itself. It's not measured. And then for the benchmark, all we do is just calling this invoke. And the invoke of the benchmark should do as little as possible, as much as necessary. So really, in best case, only calling into the generator itself or into the Roslyn component itself, but avoiding any other setup code, so that we really only measure what the source generator itself or the Roslyn component itself is using on time and their locations, and nothing else. And then we have a global cleanup, because what I saw in various benchmarks in general, that there is also one way or another some sort of unit test to assert that whatever is benchmarked actually is also correct. So I would also like to have basically an assertion phase, which is again not in the benchmark itself, but in this case for benchmark.net, for example, in the cleanup, where we can then assert this is basically now the generated code that we expect. We see the get name with the enum overloads, which basically does the switch case here, and then have some sort of assertion, but have that testing framework agnostic, so it shouldn't be depending on MS test or XUnit or NUnit, because this is not the main part of it, but only some sort of assertion at the end if everything went right. It shouldn't be used for thorough unit testing, but just as a somewhat naive check, if a plausibility check, basically. And I called those three phases initialize. So initialize for the setup, invoke for the actual invocation. So this is called a lot. Oops. This is called actually a lot by benchmark.net with this the warm-up phase and the so the warm-up phase for the cheating and so on. And eventually the cleanup, where we then do the assertion that I called inspect. So I have initialize, invoke, inspect. And I would like to now try to implement this in a more general way, which can be reused by any generator or Roslyn component benchmark. Okay. I perhaps leave this open for inspiration later on, because I wrote here this measurer already. Perhaps let's have a brief look at what we need for a source generator to work. So in the initialize, we do create a compilation, and we create the C# generator driver, which we will then use in the invoke phase to actually run the generator, which is here. And this now eventually calls into the generator under test, which, for example, looks like this. We have here a generator derived from our incremental generator, and we then actually call the logic here. And then in the inspect phase, we do a couple of assertions where we check, are there any diagnostics? So have there been some warnings that you perhaps didn't expect? Or do we indeed have the generated trees exactly one? So this setup only allows for one source file, or well, not source file is a bad word, because the file is usually the proto disk, but one source tree. So our library should also be enable to potentially check that multiple files, multiple trees have been generated, and so on and so forth. We check if the generator itself had some exceptions, and we do this all in the inspect phase. But I built this not test-driven because I had this benchmark, and I just wanted to, just under air quotes, wanted to get the benchmark work. But now this library I would like to develop test-driven so that everything really is working as expected. Okay, so I will leave this open for later reference, and let's jump into the new project. If we have a brief look, so this setup, I have samples, source, and test. I derived this from a gist. Is it gist or gist? From David Fowler. I put the link, I believe. Yes, here, the .NET project structure. Where I think this is a structure which is used by ASP.NET Core, or at least a similar structure is used by ASP.NET Core, where we have the source for the production code, test for the testing code, and eventually also a sample. I will add docs later on. And if we jump to the source, we have quite an amount of packages. Let's perhaps have a look in the Explorer. This may be a bit more revealing. So we have quite an amount of quite an amount of packages. So we have some sort of a base package which contains components or types which can be reused for every Roslyn component. Then we have separate packages for each component. So we have analyzers, we have code fixes, we have code refactorings, we have incremental generators, source generators, and suppressors. And those packages then also in the C# variant. So we have C# analyzers, benchmarking, code fix, and so on, all the 6 components that I would like to support initially. For the first version, C# only. For the next version, we could also support Visual Basic, which basically would mean to add variants for these 6, but also for this package, which is basically which contains types which are used across all components in the C# world. So basically these used by these 6 components. And we then would have all of the C# versions as Visual Basic variants. But we will start with C#. And then for each production project, there's also a test project. Perhaps to have a brief look at the rest of the structure, I will open Visual Studio Code now. So here's a docs folder, which is quite empty so far. We also have, in the root, I put a global JSON, which says, okay, to compile this project, we need at least the .NET 6 SDK. The 6.0.100 is, so this is the major version, this is the minor version, this is the feature, and the last 2 digits name I forget all the time. Let's have a look how this is called. JSON. The patch version, yes. Okay, it's the feature brand and patch version. And feature brand 1, patch version 0 is the first release of .NET 6. It's the first non-preview release of the .NET 6 SDK. And we do a roll forward policy on feature, which means it would also work with 6.1 if there was any. There won't be. Next one will be 7.0. But perhaps I could later on, when .NET 7 comes out at the end of this year, could change this to perhaps even to major forward, major roll forward. Not sure yet, but yeah, let's see how it goes. What else do we have? We have a editor config file, which defines the style of the C# code. And if we jump into the code folder, where we have the samples, the source, and the test, we not only have the solution, but also a directory.build.props, where we set the language version to C#10, because, well, the packages that we are building, target framework is .NET Standard 2.0, and the .NET Standard 2.0 language version, the default language version is C# 7.3, I believe. Let me look that up. Let's go to lang version, C#. And so yeah, .NET Standard 2.0 per default uses C# 7.3. But I want to use the latest C# features, so I force it to C# 10. Also, we enable nullable reference types. We enable implicit usings. Here we have analyzer settings. This is enabled by default for a project which target .NET 5 or higher. So again, since we target .NET Standard 2.0, we need to set this manually because there the default is false. We explicitly set the analysis level. So it includes all the analyzers that have been shipped with the .NET 6 SDK. Analysis mode all, so every analyzer is on per default. If we don't set this, there's only a handful or 2 handfuls enabled per default. Let's have a brief look at these. So it's these which are disabled, enabled per default in .NET 6. But with the all, we enable all the analyzers which have been shipped. And we also enforce the code style during the build. What I also like to set every time is if we don't do a debug build, which in our case means a release build, then we want to treat warnings as errors. And we also set explicitly code analysis, warnings as errors, which are basically those which is emitted from here. But yeah, we could omit this, but I just wanted to set it explicitly. Implicitly, it takes the setting which has been set here. So they could be controlled separate from each other. Yeah, so that's pretty much the setup. All the projects are super empty. The only things I added so far are in the super base project, in the code analysis.benchmarking package, added 3 types. So we have the base Roslyn component benchmark, where now our incremental benchmark should derive, and from which then the C# incremental incremental generator benchmark should derive. And so basically the structure could be, we have the incremental generator benchmark, which derives from this Roslyn component benchmark. Then we have a C# incremental generator benchmark, which derives from that. And later on, Visual Basic incremental generator benchmark. And these derive both from that one. So this is the hierarchy that we plan to build. And also I added two option types. The measurement options, which should contain all the setup settings for the initialize, so for the initialization of the benchmark. And we also have assertion options, which then should be used for the inspection phase, which is basically a simple test. And that's it. So let's start. Okay. Well, I will definitely get inspired from the Source Generator Cookbook. Did I link it already? No, I didn't. Because in here there is a section where they talk about how to test generators by using the Microsoft Code Analysis testing packages. So here is this is a very similar setup. So we have C# and Visual Basic version, but additionally for the testing packages, there's also a variant for MS Test, NUnit, and XUnit. And we could either use these types, or solution B suggests to do it basically manually using the generator driver that we saw, C# generator driver. There's also a Visual Basic generator driver, I think since Roslyn 3.9, which we'll be using then for the second release. But I definitely need help there, because the last Visual Basic code that I wrote was 7 years ago, so it's quite rusted. So I will take some inspiration here. Actually, let's copy this. And let's go to the C# incremental benchmarking. The approach that I'm choosing is, first of all, put everything in the most derived class, and then later on, if we no, actually, is this bad? So we have two packages. We have the let's make this a bit bigger that we see all. Yes. So which are the interesting packages for now? The language agnostic base package, then the C# base package, and both incremental generators packages. So the language agnostic incremental generator and the C# incremental generator. So these projects are interesting for now. I could do a solution filter to make it for now a bit more easy for us. So if how does this work? I can do like a save as solution filter. So let's say f0.codeanalysis.benchmarking C# dot incremental generator dot benchmarking, and let's, do we need to open that now? This did not work. Okay, let's just unload the others. Oops, I should have inverted the selection. Yes, so we have the incremental and the C# packages, and let's unload these projects. I think from here I could now, let's do the same for tests. We need this 1, 2, 3, 4. Unload. And let's save this as a solution filter. I want to replace it. That's not a solution. I need to call it solution filter, like so. I gave it the wrong file extension. Oops. Dot incremental generator. Not a solution, but a solution filter. Can't open it here. Now opened it here. Okay, now we see that, now we only have the projects. And we see that here that if we expand this, okay, it's only 9 out of 29 projects. So the hierarchy is a little bit more simpler. Hide. Okay. Okay, so in here, I actually want the root namespace to not include the benchmarking. So that I can add the folder here. And here we have now the C#. Actually, let's have a look at how Microsoft Code Analysis testing is naming these types. So that we give a similar experience to the consumer. Right, there it is. Source generators, and it is the C# source generator test. So we will call that the C# source generator benchmark. We format it. This should be public. It derives from the C# source generator benchmark, which we put into the language agnostic generator package, which also, okay, I'll everywhere added the benchmarking to the root namespace. I didn't mean to do that, so that I can add this as a namespace. And we now add the language agnostic incremental generator type. Actually, incremental. I wanted to have it the incremental first. Incremental. So this also should be public. This is abstract. It's language agnostic. It cannot be instantiated by itself. Yeah, it doesn't make sense. And this one should be incremental generator benchmark. Did it also rename the file? Excellent. And we will gonna use that. So add reference to this package Yes. Does it make sense to seal this? Perhaps. Does it make sense if a user derives from it? Maybe, but I do like to make it sealed by default. So if we see later on, oh, that makes sense to derive from that, we could always unseal it. Unsealing is a non-breaking change, but sealing, however, is. So I always like to be strict first and then make more options available later on, more non-breaking options available later on. And we need the incremental generator benchmark may now derive from the, how did I call it? The super base, the Roslyn component benchmark, yes. So we also need to add a is this type public? Yes, it is. Reference to that project. Okay, IntelliSense doesn't detect it, so let's do it manually. Add project reference, and the incremental generator benchmarking should refer to the code analysis benchmarking. Yes. And the very base now should implement this pattern. So we have public void initialize, public void invoke, public void inspect. Of course, this is all abstract as well. And the initialize should take the Roslyn measurement options as a argument, and the inspect receives the assertion options as an argument. I guess here it will make sense to have more specific options, but let's see when we need them. And here we finally need to implement them. Make block methods out of that. And let's go to the cookbook. Copy this example. And okay, well, first I need a test. So let's have a test. We build an C# incremental source generator. So this is the C# incremental generator benchmark test. File scope namespaces, public class fact. We are using XUnit, but I do need to add the using here. I want to have this automatically in all the tests. Since I have the physical structure set up like so as well, we have the samples directory, the source, and the test. So we could have a directory.build.props file in here, which then gets applied to every file here, so everyone gets the implicit using of XUnit. This would help a lot, so I don't have to add it everywhere. So let's, for a starter, add it here. Void to do. And I will have a look at well, there's two ways to add an implicit using, or another implicit using, but a global using it's either via C# code. We can say, yeah, global using. So then we don't have to specify it in all the files in this project, but I want to have it via MS build so that it gets applied to every project, which means I need to have a look at the .NET SDK repository. And in there is a usage of, or the how the implicit using is actually working. It's MS build. Implicit usings. Those are interesting. Yes. So we could say, let me go to this. Yeah, so this is for C# projects, the implicit usings that I get. Here we see them. If we enable, if we go to a project, let's go to the folder view. And if we have a look at the directory.build.props, when we enable implicit usings, what happens in the background is that now this implicit using is either true or enabled, and then these get added to that project. So let's grab. Yeah, but this is for C# project. Since we do I want it for Visual Basic? Yeah, for Visual Basic projects, not sure if implicit using is actually working. So we need to make sure that it's only working for C# projects in this hierarchy. So this is what this is for, where we additionally we have here the implicit usings true or enabled check, but also we check if the language is C#. So let's grab that. And we need a new directory build.props, okay? So we want that here, so I open a command line. I actually built a template for directory.build.props file, so let's install the template .NET new -- install f0.templates, if I would spell it correctly. And we have the .NET new, you see it here, directory.build.props. Okay, now is the file created. And yeah, we're not gonna need this. We have that. And now use the, let's jump back to the solution filter view. Let's basically have this using here. So I can now remove that. Now it doesn't compile anymore. But if I now include it here, remove the rest. Yes. Now it should just compile in a second. If I... okay. The issue I caused now is that MS Build only searches for the first directory.build.props which is found. So it doesn't go the hierarchy up anymore to select the next one as well, where we actually define that the C# version is C#10 and the implicit usings are enabled. So we need to have this multi-merging thing. I always forget the name. But I actually have this as a template, or in the template as well. So let's see the help. It's the multi-level merge, yeah. So I do -mlm. I need to force because the file is already existing. Yes, so we have this, where we say get path of above file, which basically then searches for the next one. And do we import this first? Yeah, let's first search for the, let's first go to the file up, which now is this directory.build.props, which enables implicit usings. So afterwards we can now use this. Check is it C#. Then we Actually, I need to do a language check for the other one as well, but let's do this later when we enable Visual Basic actually include in the unit here. So this should now compile if I didn't do anything wrong, but I believe I did. Well, I will have a look at this later on and fix this. Not sure what the error is, but we could also use the other variant. So we could add a file, we call it global usings, and add here the global using XUnit. And yeah, okay, that works. I will have a look at the MS build logic. There's some error. I will have a look at this later. Okay, and the first test should let's start with a benchmark. Benchmark a C# incremental generator. And for that, we need a C# incremental generator. So let's build a, let's call it the test C# incremental generator. You can make this internal, it's only used in this test assembly. Seal it. I increment. Okay, we are losing. We don't have the dependency. So for the production project, we need to add let's have a look where this is included actually. The reference to where our incremental generator is, which is in Microsoft.codeanalysis.common. But since it's the C# version, we should refer to C#. And since it's the incremental generator, we need 4.0.1. Let's install that. While we're at it, we should also install the analyzers. So that's Microsoft.codeanalysis.analyzers in the latest version, so that we use the Roslyn API correctly. But let's add that to the root directory.build.props, so that every project gets that. And I like to shorten the private assets all as so. And we added this private asset, so perhaps the consumer for our library doesn't want these analyzers. They don't necessarily need them. Okay. And I also have Microsoft Codeanalysis.c# in the props. No, this shouldn't be here. It should be only in the project here. Yes, there it is. Okay, so we can now should now be able to implement this. So, yeah, okay. The test project needs to refer to the project under test, doesn't it? So we do the C# incremental generator benchmarking test. We add as a package reference C# incremental generators. Okay. Now we can use it. Yes. Let's implement a simple generator where we have, let's just create code unconditionally. Should we use the post initialization? Let's actually do the post initialization. Let's call it post initialization action. No, not a property, a method. Yes. Did I do this right? Oh, it's actually called callback, so I should call this as well. Callback. And we have a context with which we can add source. We have the hint name and the source as a text. What should be the hint name? I call it the name of this generator.cs, and the source could be just a file. We of course want to have nullable enabled. C# nullable reference types. So we want to enable nullable, but also have the auto-generated comment, which every generated file should have. And let's create a namespace testing. And we create a public class test. Yeah, I guess that suffices. Let's give it also a name public. That suffices as a super simple test. And let's emit the source. This is a very super simple generator. So in our test, we want to set it up, invoke it, and then assert it. We have string. In this case, I don't have any user source. Perhaps later we need a more sophisticated generator which reacts on the source from the consumer. But for now, we do a benchmark. We want to initialize it, want to invoke it, and we want to inspect it. We initialize it with the new measurement options. Oh, yeah. This is abstract. Okay. So we need a. Let's create something as a default for now that we later on remove. Public. Let's create a property. Oops. Default. Private C which derives from that. Can be static. This just placeholder. This will go away later on. And for the inspect, we need the Roslyn assertion options. But here we want to pass the expected source actually. So we have a string expected or generated. I pass in something wrong so that we can see it actually failing. Okay, and for this, so this is actually C# code. So we definitely need some C# assertion options, which allows C# code. So let's jump to the C# benchmarking project again. Create a folder where we put in the C# assertion options. They derive from the Roslyn. Okay, we need to Roslyn assertion options. Can we, yes, reference the base project. Did this not work? The typo namespace could not be found. Also. Dot code analysis. No, it's in this namespace, isn't it? Why is it not found? No, it does work. Okay. And we want to have a property string that we call, let's make it nullable because perhaps it's optional, maybe it doesn't generate anything. Generated source. Let's make it init only. The is_external init is not defined or imported. Yes, because we're on .NET Standard 2.0, so we need a package for that, but actually I wrote this as a generator, so we can add this generator, which is the fco.compatibility. And I guess this makes sense to be in the root, I guess, as well. So let's put it to the, no, I guess only the production projects really need that. So we could again create a directory.build.props, but this time not for the testing folder, but for the production hierarchy with the multi-level merging enabled. We import above and post in this private assets all and this now should, okay, I do something wrong with the director.build.props setup. So let's use it for now in the benchmark in the project directly. Okay, so now the generator actually creates this sysexternal init. That's in system.compiler is external init. System.runtime.compiler services.is external init. Yeah, so that's the one. This is generated by a generator, and this type needs to be available for C# 9 and above in order to enable the init only keyword. Okay, so we can set the generated source. Let's new our C#. No, C# assertion options. And set. Actually, I should have it, but the generator doesn't work, no. The generated source to that. And yeah, this should be a first failing test. It does fail indeed. Yeah, something is not implemented. Cool. Okay, so we should implement it. For the initialize, we need, okay, now we can get the inspiration here. So we need this C# generator driver. We need to create that one. Let's do a field. Oops. So not generator. I wanted this to be as a field. Private. Okay, this maybe now. We need to make sure that we call it in the right order. And this gets passed in an incremental, an incremental generator, a collection of incremental generators. Actually, well, it's params. Okay, so we need to instantiate the generator. So let's make this generic. T incremental generator, where T incremental generator is I incremental generator, and also new, so that we can instantiate it. Let's do this in the constructor. Private T incremental generator, I incremental generator. Can make that one read only. Equals new T incremental generator. Okay, so we have the generator. And let's see what the test is saying. Oops, compiler error, because, okay, now we need to give this a type, which will be our test C# incremental generator. Okay, that's the generator we wrote, the simple one, yes. Oh, not live share, test explorer. And it fails because still something is not implemented. The inspect and the invoke. Okay, let's actually have this do nothing for now. And we have a passing test, but we actually want it to fail because the string doesn't match. So we need to run it actually. For that we need, okay, we create a new instance of the generator, run the generator. Okay, so this is the invocation. The invocation does nothing else other than run the generator. We need to make sure that the invoke actually has been called. So if driver is null, then we should throw an invalid. Perhaps this initialize invoke is not the best because we could call it in the wrong order, then it doesn't work. Maybe there's a better approach to make it, but order is kind of relevant. Perhaps I change it later on. Let's see how this goes. Saying that that the benchmark has not been initialized. Please invoke, please call initialize first. Okay, and we need an input compilation. So the one generators and update compilation. There's also a one generators, which doesn't. What's the reason of that? So we don't get a compilation, but I guess we need the compilation in order to get errors and such. So let's use the, one generators and update compilation. We have an input compilation and output compilation. We get diagnostics and we may cancel it. Okay, let's actually use the explicit type here. Okay, we need the input compilation. This is also initialized. So we private need our input compilation. So if the driver is null or if the input compilation is null, so we need to create compilation. And for that, well, since we are in the C# namespace, we can create a C# compilation, because the C# compilation is actually creatable. It's not newable. Does not have a constructor which contains. Doesn't seem to have any visible constructor. Is there perhaps a create method on it? Great, yes. Actually, I could have looked down here. Yes, okay. They also use a create method in the cookbook, so I'm using that actually. And that's the point. The point is into the protection. Okay, that's a different binder, isn't it? We create the calculation where we pass in the source. Okay, and we got this from the option start. We don't have a source yet. Okay, so for now we have null actually. Or should we perhaps do an empty string instead? Because how do we create? We pass here the text, and that gets text. This is not nullable. But we have options. Okay, so later on we could also pass options and a path. Okay, but we expand on this as we need it. This indeed could be static. Output kind is a console application. I prefer library. Okay. And it passes, but it shouldn't because we don't do anything in the with the result. Okay, so in the invoke we get an output compilation and diagnostics. So we should store this output compilation. And also the diagnostics. Yes. And in here we can now, let's see how they are doing it. I guess they do some assertion. Let's use, actually let's get all of this. This seems to be code for the inspection phase. Okay, so we actually need to assert. If diagnostics is empty, if they aren't empty, throw new. Okay, we need an assertion exception. Cool. But we don't need it to be serializable. Should we make it public? I guess it's best practice to make the exception public. And we throw that with unexpected diagnostic. And we, how do we do this best? String.join. Messages. Let's do an IEnumerable of string, which are messages. diagnostics dot select. Let's do some link. Diagnostic goes to, let's make this static. Can we toString this? Suppression info. Let's toString this. And we join these messages by, oh, first comes the separator. Let's do a space, space, dash, space. Okay. This, well, actually, I don't have a test for that, so I need to add this later. Here we have a look if we indeed have two syntax trees, so the original one and the added one. If we don't have two, okay, if we have a, if the output compilation is null, then invalid operation exception, because let's use this message. Benchmark has not been invoked. Call invoke first. And if it is, we throw a new assertion exception. Expected two syntax trees but found okay, I call link count twice here, so this is not best for performance, but yeah, I guess the test failed. It isn't crucial here, since this is not in the invocation phase, but in the inspection, performance is not crucial. Okay, so this may already help. Let's also have a test here. There's no diagnostics. If this is not empty, generated output compilation had produced diagnostics. Oh, time is flying. We only have half an hour left. I will do this later. To do something is wrong. Then with a driver we can get the result. Okay, so driver must also be not null. Contains the combined result of all generators. Okay. Expected one generated but found. If this is not one, okay, diagnostic should also be empty. So again, I'll do a to-do to make this, make a nice output there later. Result produced contained diagnostics. For quick, let's say .length here. But to do print Static messages. And then we check the first result. Somewhere we need to check the code actually. I'll comment this out because I really want to check the code. So the generator 1 result has generated sources. Here's the syntax tree. And the source text. Yes, this looks good. So we can say if the generator result dot generated sources, which is a collection, also at position 0, the source text of it, and source text, how do I get the actual string? I guess via toString. Yeah. Where's the word text? toString. And this should equal what we expect. So we have our options dot we need the C# assertion options. And they have the generated source. And if this is not true, okay, we also need to pass string comparison. Let's do ordinal. Well, we can use diffplex here to get a nice diff view. I built this already, so I'm really copying that. It doesn't make sense to really write again. I have it here. I can create a diff from 2 different strings and then print it. Cool. Oops, wrong project. For that we need diffplex. This is this package. Let's see if there's a newer version of it. Yes, there is. We diff the actual with the generated source. So we have the original and modified. How did I do this in the other solution? Put in the expected and the actual. Let's grab that. We have the actual and our expected is this here, expected actual source differ, and we have an assertion exception. Yes. Options, possible null reference of the generated source. Oh yeah. Do we allow null here? I guess it could be empty but not really null, so perhaps we should disallow null here, but set it to string.empty per default. Okay. 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 Now we have a, yes, the The base type uses a more generic type, so I guess we could new this. Do we then actually override it? This doesn't work with new. Aha, if I don't make it abstract but virtual. Or perhaps, or should I get rid of this base types entirely because they are super empty and don't really add any value, do they? I will add them later on if I actually need them. So for now, let's create here a C# assertion option, the C# measurement options. Seal it for now. And we use these. Okay. I need to overthink the hierarchy. For now, I get rid of this. I need to rethink that later on. And we can now here have we no longer have an override. You have the C# measurement options and the C# assertion options. All right. Yeah, perhaps the base class makes sense later on when we have actually multiple variations, but maybe it doesn't. Let's perhaps an empty makes sense. Yeah, default. I guess default makes sense. So let's also create a default here. And also for these. Okay. C# measurement options and new generated options. Okay, let's go. And it passes. But why? Okay, we don't check this for now, so let's do that. Because I do have warnings as errors, this wouldn't work in release build. Is null, throw new argument null exception with name of options. There's a shorter version of this with a discard if it is null. Actually, if it is null, then throw. Yes. Okay, now the warning goes away, but it. Let's see. Breakpoint. Ah, there's the breakpoint. If you actually get there. The actual is Okay, can zoom in, but we see there is some auto-generated nullable enable testing, so there is actually code. Ah, yes, if it equals. So if it does not equal, then we should throw, yeah, we expect it to be equal. And now the test fails. And we have, I put this into just Studio Code. So this is the exception that we get. So we have here the nice diff. So the one has a minus before, the other have a plus before. So we expected this, but had this. Which means we can now go back to fix the test. We'll go ahead and, so the generator is actually working, and in the inspect phase, we get the real output of it. So we can jump to the test. Let's copy the string. And if I omit one space, what happens is that the test fails with, so there is some empty plus here, missing space. And now if I add it and run it, it should turn green. Which it does. Okay, so that's basically, this is how we can run benchmarks already. Super basic setup. How much time do we have? 20 minutes. I want to set parse options. And also, well, actually, first, let's have some input to the generator. Okay, we always generate this, but let's make the generator, let's not do post initialization, let's actually, what is a simple, no, I want to, okay, I guess in 20 minutes I can do a simple generator which inspects user code, and then depending on the user code, emit something. Perhaps, I guess what I will do, I do this immediately after our session ends. Like to implement string overload. So if I find an abstract, a partial, not an abstract, but if I find a partial string method, like any method, then implement or add source partial string method, which returns hello world. But for now, I want to do something which could be done in 20 minutes with the parse options, because this is actually something that my previous generator, not generator, but a benchmark couldn't handle. So the only input allowed, this is now the benchmark I wrote for the already existing generator. The only input we allow is like expected source, and for the input, so this is like we can only assert a source and we can input source, but we can't set parse options or anything like that. So this will be already a huge improvement. So in here I want to add the compilation provider. Yeah, and basically use that to say context dot output, which is the output, which is the source output, which is the source output gets incremental value provider and an action. So this will be our provider, and we get the source production context. I call it execute, because in incremental source generators, it's the execute phase. So let's put this, let's get rid of the post initialization. And let's create source depending on the compilation. So we have compilation. Actually, what we should do is mark this as a generator, which is C#. And this can be static. Let's paste in here what we had. Let's make this no longer const, but let's say, okay, we have here a C#10. No, it is actually C#9. And let's also do a C#10 version of this, where we have, rather than a block scoped namespace, we have a file scope namespace. And depending on the compilation, so since we say here, okay, should be C#, we can cast this to the C#. And it's not the compilation that I'm searching, it's the parse options actually. So we need the parse options provider. We pass in parse options. And we can C# parse options. We don't have the type available. Where do the C# parse options live? Let's go to Roslyn source. Source Roslyn, I always forget the source browser. So I go to sites.of.net. It's sitesof.net. And here's that's the BCL. Here is the Roslyn source. C# parse options. They live in Microsoft. Is that a namespace or the project? Microsoft Code Analysis C#. Do we not have that dependency here actually? Well, we do refer to incremental generator. Okay. No, there it is. C# incremental generator benchmarking. And C# incremental generator benchmarking. Microsoft should be available. I didn't put it as private as it's all. I'm just missing the using. Okay. So we cast these. And the C# parse options now have a language version. And if this language version is, let's do a string source, if the language version is greater than or equals to C#10, then we use C#10, otherwise C#9. Okay. Now we create source depending on which parse options we give in. So we could change this to 2 tests. Let's make a theory out of that and pass in not inline data options, but what's the data options? Test case. Not inline data, but member data, yes. Name of data. Test data. What's that? I always forget. There should be an enumerable of the strongly typed XUnit strongly typed test data. There's a blog by Andrew Locke. This one. Theory data. Yes. How does this work? We add goes to that. So we have a string and parse options. We have our data and Yoda LPB. I have a new follower. Thank you very much for following. Not sure when you joined in, but we are building here a library for benchmarking of Roslyn components, and right now we are in the C# incremental generator world. So we're building a test to verify that our generator is, depending on the language version that we put in, generating different sources. And for that we use XUnit, and we have a theory data of the C# parse options. Actually the language version suffices. And a string, which is our source. I think this is an enumerable, isn't it? So we can use a collection initializer. Where we say for language version C#10, we use this string. So we say again, oops, const string C#10. But for C#9, we use the C#9 version of things. And C#9, we don't have a file scope namespace, so we use a block scope namespace, and I just did it vice versa. So C#, this needs to be switched. Let's switch names, simpler. So C#9 has block scope namespaces, C#10 allows file scope namespaces. Okay, and this will be our input for this test. So we pass in a language version and the expected source. Expected source is generated, okay, but how do we pass in the language version? For that we want to set C# parse options actually. So we want to allow we need C# parse options on that type. C# parse options, because they contain the language. I have a typo. C# parse options. I don't have them available in this package. Yes, because what we saw, we need to refer to Microsoft.codeanalysis.c#. This is where the C# parse options are included. Let's use the version here, but I guess we can lower it later on. But this works for now. I want to get this test working before we close. C# parse options. Now I have an issue with this external init again. Did I remove the generator? It's still there. Okay, I'm not sure what's the issue here, but I just define it myself. Add new item is external init, which must live in system.runtime services, I think. System runtime.compiler services, yes. This is the namespace, and we say is external init, and I think this class just needs to exist. Can be static. Now this should work. Yes, now the error goes away, because we just need the type to be available for .NET Standard 2.0 to enable init-only keywords, init-only properties. Okay, so we have C# parse options, and here we can set the language version. So we use some default, but we can override them. So we say parse options equals new C# parse option. Oops. Options, here they are, and we pass in the language version that we get in from the test. Okay, here we must return the data, and this does not compile because the theory data is of type language, version, and string. And this is so it's not an enumerable theory data because theory data already is enumerable. Okay, remove the underscores from member names. Yeah, I will take care of the warnings later on. For this, I actually have an analyze suppressor to allow underscores in unit test names. I will include this later on. Let's first get the test green. But it's red because, okay, we have one passing, but one is failing. Yes, okay. So we have an issue in spacing it. I may use the wrong expected actually. So we expect what's that? We expect a file scope namespace, but actually have a block scope namespace for the test, which takes in C#9. Yes, because we don't use the parse options actually. That's the thing. We now need to implement it. So we need to parse. Okay, the parse options must be part of the compilation. No, where do we, the input compilation, where do we set the parse options? Are those part of the compilation? I don't think so. So where can we pass them in? Data C# compilation options, and C# compilation options, they don't have parse options, do they? How can we set the pass options for this generator? We can, here we can set additional text and pass options. There we are. Okay, so I actually put it at the wrong, I put it to the, I can't add this to the inspection phase. That's too late. This needs to be part of the initialization phase, of course. So let's add it to here. So we create new, this is gone. Create new options, and these options now get the pass options with the language version. And in the initialize phase, we then actually have the driver here, where we call into this overload. Let's copy this. This will be our overload that we need to fulfill. We have 2 minutes left. I will go over by 5 or 10 minutes. We need generators. Okay, since we no longer have the params, we need to create this ourselves. So we have bar generators. Well, let's make an I incremental generator array. These are our generators. New array of my one generator that we initialize in the, sorry for jumping around, hit the wrong key, in the constructor. So we use this one here, pass it in here, and now we have the overload where we can set additional texts. We don't have any additional texts. We may want to also allow that, and set the C# pass options that we get from the options. And this does not fulfill the overload because array, okay, and it needs to be an IEnumerable. So IEnumerable of incremental generator. Here we create a new generator array. Now this should fulfill the, oh, there is no overload which takes incremental generators. So I guess we need to dot as source generator, this one. So this is no longer an incremental generator, but an I source generator collection. I source generator. Yeah, and this does not, cannot be convert from, so array, be gone. Okay, now we call the correct overload. We should null check, we already have a null check. Since it's a public method, we need to null check what the user passes in here. Options must not be null. Okay, and we pass in the pass options to the driver, and this could make the test pass. So both of them. It does not yet. So what's the issue? Inconsistent language version, syntax trees. Pass text. Pass text also gets options here, so we may want to pass them down. Here as well, and we feed them in here. Pass options start. Okay. So now we use the same pass options for the generator driver and the syntax tree that we create. And both tests pass. Cool. So we have want to do definitely is to also allow for different metadata references. Parameterize. This should be an input. yeah, other than that, I guess it's pretty good. Let's call this benchmark. Generated benchmark. Generated benchmark compilation. Okay, and where's the other to do? Yeah, make this a little bit prettier. Before we close, let's see if this is all also working in release build, or if we have any warnings left. For example, some nullable warnings. Yes, we do have some warnings. Okay, we need to remove the underscores from here, but I do have a diagnostic suppressor which suppresses this, the CA7007. We actually built that one in a previous stream, so let's use it. I think I included it already in one project, haven't I? Yes, there it is. Oh no, that's a different one. Ah, that's the analyzers. Never mind. So let's add that here. That's f0.analyzers, which contains that suppressor, and that's version 10. 0.10. So now, yeah, so this warning now goes away because the suppressor suppresses the rule CA1707 if this is a test method, which is here denoted by the theory. But we are not allowed to have underscores here. So let's just remove them because this is not a test method. Generator. So let's build, and it succeeds. We have no warnings, and our two tests also work in release me build, I suppose. Excellent. And this will be the session for today. Unlike previously, where I only streamed on a fortnightly basis, I will now switch to a weekly schedule. So every Sunday at 7 a.m. UTC, I will stream for 2 hours and will continue this project until it is completed, at least the first version of it, which shall include these benchmarking types for these Roslyn components. Currently, we're working on the I incremental generator, and this is where we will continue next time. I guess off stream I will clean up the code a little bit and also have a look at the this directory.build.props hierarchy is not working. And I will do a brief sum up at the beginning of the next session, what I did off stream, but I won't change too much about the logic. Perhaps I change something about the structure calling convention here. I will think about this a lot. Actually, I will think about it, but not change it. I will change it to change this then in the next stream in a week. So yeah, let's go back to the discussion. All the links that we opened here throughout our stream, I will add to the resources here. So this will be one complete documentation of what we searched and what we needed in order to build eventually build this benchmarking library for Roslyn components. And for the next session, I will prepare an agenda, which is, on the 5th of June, same time, same place. And with that, I want to thank you very much for staying a while and listening, and may Roslyn be with you. Until next time. I guess I exited too early. I should have started my companion here already. There it is. Goodbye.